In this lecture, we'll focus on perspectival grids. First, we'll draw one into the quad we started and talk about further possibilities for that drawing. Then we'll look at some of the ways we can use grids to measure the depth of space in a drawing. Let's return to Raphael, Canaletto, and the Simpsons animators. In all three examples, a pattern based on a grid recedes along the ground plane. We'll add one now in the open space of the quad. We'll start by dividing the front edge, the very first line we made, into 10 1-inch increments. Next, we'll vanish these back. Try adjusting the pressure as you draw these lines. Greater line weight forward, less as you recede. Then place your straight edge corner to corner across the quad, and make tick marks where the diagonal traverses the receding lines. Then draw horizontal at each one, and erase the tick marks. You now have a receding gridded floor plane. We can create a broad path leading back through the quad by erasing the central vanishing line and the horizontal line segments within the path. We'll create a second path intersecting this by erasing the two center rows 5 and 6. Let's draw a central door for the building on the left. Carry the vertical lines up from where the path intersects a building, and lastly, erase the prior vertical. You now have a grasp of many of the basic principles used in one-point perspective. You'll really make it your own by spending more time with this drawing. It's all about repeating and embroidering on the procedures we've used. You could do a lot more with the interior furnishings. Take the bed further. Try constructing a couple pillows on top of the blanket, or turn the block-like base of the bed into a four-legged base. You could try adding bedside tables on either side of the bed and put a painting on the wall. If you do, make sure to give it thickness. And you could throw a rug on the floor under the bed. Slightly softening the hard corners of the bed and other objects will lend them a much more naturalistic feel. Moving through the buildings, you can construct a range of things: desks, chairs, bookshelves, a sofa, kitchen counters, a sink, stove, a refrigerator, or a ping-pong table or swimming pool. On the exterior, you could construct volumetric doors. You could also create windows of varying sizes, thicknesses, and type. Some might be recessed, and others protrude with a ledge. Others yet might have additional molding. You could also try drawing some benches or additional elements outside in the quad. On a grander scale, you could extend out on either side of the buildings we've constructed, and extend from the buildings in quad both forward and backward in space. It's important to know, though, that it's possible to run into distortion, as I mentioned in an earlier lecture. But we're experimenting here, so if you do, just take note of it. Distortion's built into the perspectival system. It kicks in as you get farther away from the vanishing point. As we move out to the right or to the left or above and below, things will eventually distort. Of course, some artists use perspectival distortions, fisheye warping, and spatial ambiguity purposefully. M.C. Escher comes readily to mind. The essential factor is to be aware of the fact. In any case, over the coming days, pay attention to all the things you see that you could use in your quad drawing: buildings, furniture, mailboxes, street lamps, utility poles, and the like. Also pay attention to paintings, drawings, cartoons, and video games that make use of one-point perspective. They're ubiquitous, and they'll suggest things to ignite your imagination. You just constructed a perspectival grid, and I'd like to take this further, because grids can be very useful to us in measuring space. Here's a 10 by 10 inch square. Let's imagine it's a drawing of a 10 by 10 foot wall. I want to draw a 3 by 4 foot window in the wall, and I want to locate it 5 feet off the ground and centered in the wall. No problem. I know the scale, 1 inch equals 1 foot. I measure with my ruler and draw my window. Let's also imagine I have a floor. Say I wanted to draw a carpet centered in the floor, and I want its front edge 1 foot from the picture plane, and I want the carpet itself to be 8 feet wide by 7 feet deep. Well, now I've got a problem. I can't measure into the illusionistic space of the drawing with my ruler. Let's return to our back wall. If it had been tiled with 1 foot square tiles, I wouldn't have needed the ruler. Count tiles or grid units, and I can draw the window. And this solves the carpet problem. We can't push a ruler through the picture plane, but we can draw a perspectival grid that will serve the same purpose. count back 1 tile to find the front edge of the carpet, center an 8-unit width, count back 7 feet in depth, draw the carpet. If we grid all the planes, we're able to make specific measurements into space throughout the drawing. And this is very useful, particularly when we draw from our imaginations. It allows us to scale all the elements we draw. Place a table that's 2.5 feet tall, 3 feet wide, and 6 feet deep, 3 feet from the picture plane in the center of the room, no problem. Draw a man 7 feet tall standing on top of the table, again, no problem. And if we want a woman 6 feet tall, 15 feet behind him, that's all doable. We can even draw things in specific locations in midair. Here's a 2-foot cube floating 6 feet off the floor. It's 4 feet back from the picture plane and 2 feet from the left wall. So this is very useful when you draw from your imagination, especially when you want to tie everything together in specific proportion and measure. Our next project involves drawing a gridded room similar to the one in the example. You'll also draw objects in the room. Each will have a specific measure, and each will be drawn in a precise location in space. For this to work, the grid units just can't be any kind of foreshortened rectangle. They have to look like foreshortened squares. So we'll have to dig a little deeper into grid construction. Before we do, let's recap what we've learned so far. We can grid a receding plane like a wall. First, we divide its vertical edge into equal units and vanish these divisions back to a vanishing point. Then we draw a diagonal line across the plane from one corner to its opposite. Where this diagonal traverses the receding lines, we draw verticals. This produces a grid with as many receding divisions as there had been divisions along the wall's front edge. 4 divisions along the vertical edge means we'll get 4 receding units. We found the same thing holds true for a floor plane. In the quad's ground plane, we had 10 divisions along the horizontal axis, receding into space toward the vanishing point. We drew a diagonal construction line, corner to corner, traversing the plane. We noted the points of intersection and drew a horizontal at each traverse. Then erased the construction lines to reveal a proportionate diminishing grid. While we've been controlling the number of receding grid units by controlling the number of divisions on the axis, we haven't controlled their shape. Instead, this was the result of the number of original divisions on the plane's horizontal or vertical axis. It's also a byproduct of the overall shape of the plane, the floor or wall itself. Let's compare our 2 examples. I've rotated the wall 90 degrees to make this clearer. 4 divisions and a less foreshortened plane clearly result in taller grid units. To isolate the effect of the number of divisions on the ground line, let's use identical floor planes. Same thing, though less pronounced. Whatever the degree of foreshortening of the original plane, fewer divisions along the axis or ground line will result in less foreshortened grid units. More divisions, more foreshortening. So, if I had 20 divisions along the ground line, the individual grid units would all be even more foreshortened. Here's the point. I want my receding grid units to look like receding squares. If I want to determine the number of grid units along the ground line and also want to control the shape of the grid units, I'll have to adjust the procedure. To help make this clear, let's imagine a grid, 10 by 10 squares, centered and parallel to the picture plane. Now, let's add a second grid on top of the first and lower it down to the ground plane. The diagonals of the second grid are now receding to a central vanishing point on the horizon. That equates with eye level, in this case, the height of the center of the camera's lens. Take a look at the first row of tiles and note their height relative to the upright grid. Smaller. Gotta be. They're foreshortened. Now, let's raise the camera. The horizon and vanishing point move up too. And look at the vertical height of the first row of grid units. Taller than before. Less foreshortened, though still less than the upright grid. Let's take the camera lower. The first recession gets shorter, more foreshortened. As we lower eye level in the horizon, the grid units get smaller and smaller, more and more foreshortened. If we cut a hole in the floor and could get the camera all the way down to the ground level, we'd see the floor and the grid compressed into a single line. It'd disappear. And this is a key we'll use to construct a grid that feels like a square. We'll estimate the first recession, the vertical height of the first row, based on the height of the horizon. High horizon, taller; low horizon, shorter. Let's say I'm marking off 2-inch units on my horizontal axis with the goal of creating a perspectival grid of squares going back into space. A non-foreshortened square would be 2 by 2 inches. If I had a high horizon, I'd make my first recession closer to 2 inches, say 1.5 to 1.75 inches above the ground line. If I had a mid-horizon, I'd try 1 inch to 1.25 inches above the ground line. A lower horizon yet, and I'd go down to 3/4 or 1/2 inch to start. In each case, eyeball that first recession to make sure it looks like a square in a foreshortened view. And, as mentioned earlier, be alert to distortion that may occur as you move far right and far left, as well as when you're projecting well forward in space. My students get good results using this intuitive method. There's a much more precise way to assess the first recession. It's part of what's termed mechanical perspective. It involves drawing a plan, a view seen from above. You locate both what's being drawn and the location of the person drawing it. That's that station point. We're not going to cover this method here, but if you're interested, you'll find this explained step by step in many books on linear perspective. We've now gone over most of what we'll need to know to move forward with the drawing. So take out a new sheet of 18 by 24-inch paper, fix it to your drawing board in the vertical or portrait position. One caution: all the lines in our gridded room are construction lines. In other words, we're drawing the grid so that we can locate other things later. But we'll also be using construction lines to generate the grid itself. So we have a couple layers of construction lines. You'll want your horizon and the construction lines used to generate the grid to be the lightest and thinnest, say 4H. The grid could be H or 2H. This leaves you a lot of room from F to 10B to draw things later. As we did in the quad drawing, keep your pencils well sharpened to control line thickness, or use mechanical pencils. And check your hands and tools for graphite residue, wash and dry as needed. We'll start out with a 16-inch horizontal line, a ground line, 2 inches above the bottom of the page. This will also be the bottom edge of the drawing's format shape. Next, draw a horizon line 10 inches above the ground line. Locate a central vanishing point or crosshairs at the 9-inch mark on this line. Now, we'll divide the ground line into 2-inch increments. Make these marks as small as possible. Our scale at the picture plane is 2 inches equals 1 foot. If the finished grid were tilted up from the ground plane so that it was pressed up against the picture plane, we'd see that each grid unit, each square, measured 2 by 2 inches. And the only place that this true measure will reveal itself will be on the picture plane, or at the edge of the format shape. Same thing, really. Take time with each step. Small errors can compound, resulting in major headaches. Now, we'll line up these marks with the vanishing point and draw receding lines. As we did before, change pressure, meaning line weight, with spatial depth. This will lend a sense of atmospheric perspective to the lines and aid in the illusion of depth. Remember, don't touch that vanishing point, keep it pristine. You can erase any extra measure marks you have at the 2-inch intervals on the ground line, and we're ready to set the first horizontal recession in our grid. We have a middish horizon, so we'll locate the first recession at 1 1/4 inches above the ground line. Eyeball it to see if these look like foreshortened squares. I think they're pretty good. We're ready to draw the grid, but here our situation is different than it was in the quad. In that drawing, we'd already defined our large ground plane and used the diagonal of the whole plane to locate the recessions. Here, we haven't decided where the plane ends. We'll be drawing a floor with 12 rows of tiles, but we don't yet know where the back of the 12th row will be. Let's take a little detour to figure this out. If we tilt up the grid to an upright position, flat against the picture plane, it'll help us understand what we need to do. If we had the first row of squares in this position, we could use our ruler to measure 2-inch increments all along the vertical axis and complete the grid. But there's another way that doesn't entail measurement. Think about it for a moment. Might want to pause here. Many of you likely got it. The solution involves drawing a diagonal through the opposite corners of one of the bottom squares, and then projecting that diagonal across the vertical lines. We note where the diagonal crosses the verticals, and draw a horizontal at each traverse to create the grid. And this will work precisely the same way in the foreshortened position. We draw a diagonal, very light and thin, through the opposite corners of one of the bottom foreshortened squares. We carry that diagonal across our receding lines. Actually, it's better not to draw the whole line. I've done it to make the example clearer, but you could just make small marks on each receding line where the diagonal would traverse it. It saves some erasing. At each traverse, draw a horizontal. Make the lines lighter and thinner as you recede. We're at a crucial point here. Check your grid and make sure each of the horizontals is really horizontal, not angled. Also check to make sure that each successive row is smaller than the one preceding. When everything checks out, you're ready to move on. We have 8 rows equaling 8 feet of depth. We want 12, so we'll use the diagonal again to get 4 more receding rows. Project a diagonal across the first unit on the left of the last row. Mark where this traverses the receding diagonals. You may have noticed that our 2 diagonals appear as if they would intersect if they were extended, and they would. They'd meet on the horizon at a place called the right diagonal vanishing point. If we'd drawn our diagonals from right to left, these diagonals would have terminated at a left diagonal vanishing point. All the diagonals we could draw through opposite corners of the floor's grid units would terminate at one of these points. In this drawing, they're off the page, but they can be useful for checking to make sure that everything is lining up correctly. In any case, we have what we need to finish this gridded plane. Draw on 4 more horizontals, then check for accuracy. Erase the tick marks on the receding lines as well as any receding lines beyond the final row. Now's a good time to check your line weights. We're trying to achieve a sense of atmospheric perspective to enhance the effects of linear perspective. The lines should be getting lighter and thinner as they recede. Closer, more contrast; farther away, less. Complicating matters, and due to foreshortening, the lines representing the more distant tiles wind up closer together. This has the optical effect of making the overall line grouping seem darker than it would be if the lines were spaced farther apart. You can use your kneaded eraser to great advantage to lower the volume on individual lines and groups of lines that are too dark. Pull the eraser across with a small amount of pressure to adjust the contrast. Repeat as needed. Check everything one more time. If it looks good, this part's done. We'll add a right wall, left wall, back wall, and a ceiling. Each new plane should go more quickly because we'll be able to carry information from one plane to the next, assuming what you've got so far is accurate. We'll start with the right wall. From the bottom right edge of the ground line, draw an 18-inch vertical line. This will define the right edge of the format shape. This, like the ground line, is on the picture plane. This means we can use our ruler to measure here, just like we did with the ground line. Mark off 2-inch increments along this vertical axis. Since we now know where the wall will end, draw a vertical to define its far edge. We can vanish the 2-inch increments back toward the vanishing point. This time we know where they should end, at that wall's back edge. Next, we'll carry the measure of the first horizontal recession vertically up along the right wall. Line up your straight edge along the diagonal of the bottom foreshortened square. Then mark the traverse of the extended diagonal on the receding diagonals. Once again, I've used a continuous line so it's easier to see. You can use both the horizontal recessions on the floor and the diagonal to draw the vertically receding rows of tiles. They should agree. When you get to the 8th row, you can repeat the use of the diagonal to find the final 4 recessions. These 2 diagonals would meet directly above the central vanishing point. That would be the upper vertical diagonal vanishing point. And as you may have guessed, if we'd drawn the diagonals in the other direction, upper right to lower left, they'd have met at a point below the horizon. That would be the lower vertical diagonal vanishing point. Finish this wall and erase any extra construction line. Using your kneaded eraser, adjust the line weights. You want the wall and floor to feel the same at equal depths. If you've been conscientious, it'll get pretty easy now. Follow the same steps to build the left wall. As you're making your way through this, check to make sure that the left side is level with the right. Pick 2 points that should correspond. Use your T-square to verify that they're level. Once again, use your kneaded eraser to adjust line weights on the left. If all this is right, drawing the back wall is simply a matter of connecting horizontals from the 2 side walls, then extending verticals up from the floor. Now we can identify the viewer's eye level. We just count up the back wall to the horizon. The scene is being viewed from a height of 5 feet. And adjust the line weights on the back wall. Drawing the ceiling involves repeating what we did on the floor. This time, though, we can pull placement information from the 3 planes that abut and are already completed. Using the diagonals provides another way to check that we're getting our lines in the right places. You don't actually have to draw the lines, just line up your ruler and make sure things are falling where they should. The ceiling diagonals should vanish to the same point as the floor diagonals. When you finish drawing the ceiling, check the line weights all around. At each depth of space, there should be a general correspondence. Congratulations, you've drawn a gridded room. Now you're ready to draw objects of specific measure in specific locations. We'll draw a door, a bulletin board, a light fixture, and a box on the ground. We'll block these in with simple shapes to mark the locations, then turn them into specific objects. First, let's draw a 6 by 3 foot door in the right wall. We'll locate this at a depth of 4 feet from the picture plane. Where the right wall meets the floor, count back 4 feet. Make a small mark here. Then up 6, another mark. Then back 3, another mark, and down to the floor. Lightly outline the door's location. Let's draw a bulletin board next. We'll make it 3 feet tall and 8 feet wide. That's 8 feet receding into the room. We'll put it on the left wall at a height of 4 feet and a depth of 2 feet from the picture plane. Start at the left edge of the ground line. Count up 4 feet. Then 2 feet in. Make a mark. Now up 3 feet. Make a mark. And back 8 feet. Make a mark. Down 3. Last mark. And you can draw the board shape. Next, we'll draw a light fixture that's 6 feet wide and 2 feet deep. We'll put it in the center of the ceiling. It'll straddle the 6th and 7th rows of tiles. Last, we'll draw a box on the floor. The box is 4 feet tall and 2 feet in both other dimensions. We'll locate it at a depth of 1 foot from the picture plane and 2 feet from the left wall. Now this is a little trickier, so let me take you through it step by step. We'll need to draw a series of construction lines to understand the box's placement. First, we'll draw its footprint, 2 feet by 2 feet. Locate this 2 feet from the left wall and 1 foot in from the picture plane. Next, on the left wall, at a depth of 1 foot from the picture plane, note the box's 4 foot height with a vertical line. Now, carry the height measurement over the footprint with a horizontal construction line. This locates the box's front face, and you can draw it in. Then, erase all the construction lines except for the footprint. To finish the box, draw receding lines toward the vanishing point from both top corners. Then, bring a vertical up from the footprint's rear left corner. Let this intersect the diagonal above it. This point defines the box's back edge. Now you can draw the back edge of the top of the box and erase the last construction lines. You may have noted the unusual position of the right side of the box. It falls in line with the vanishing point. It means that the line defining the right edge of the top plane is not a diagonal, even though it's receding to the vanishing point. It's a vertical. The same is true of the bottom right edge of the box. That was the part of the footprint sitting on the floor. And both these lines are identical to the vertical right side of the box. All fall in line together. Generally, when artists are trying to create an unambiguous depth of space, they'll avoid lining things up like this. On the other hand, many artists, especially in the West starting in the late 19th century like Bonnard and Matisse, were interested in playing spatial games and would embrace this kind of alignment. This vertical is part of a larger XY axis that straddles the room. Let's look at the central grid line which passes through the vanishing point. First, it appears to recede from the ground line to the back wall, then climbs up the back wall and finally comes forward in space along the ceiling, returning to the picture plane. The grid line that passes horizontally through the vanishing point has a similar quality. It appears to recede into space back along the left wall. At the back of the room, it traverses the back wall, then returns forward to the picture plane along the right wall. But both the first and the second are nothing more than straight lines, a vertical and a horizontal making a big plus sign on the surface of the picture plane. But they also appear to pivot into the 3D space of the drawing. That's a clear ambiguity. Returning to our drawing, what we've done so far is to create a base for a drawing. Here's one of my students' drawings. Though the proportions of the room, the horizon height are slightly different, you should have something akin to this on your own drawing board. The goal now is to work into this. Embroider. Use what you've learned about perspective to give everything dimension. Make the objects feel three-dimensional and specific. Note in this drawing how the door, the corkboard, and the light fixture have been given thickness and dimension and projected into the space of the room. The door has a volumetric doorknob, and volumetric hinges too, built out of little cylinders. The corkboard has both internal and external planes. You'll also note that the objects stand out from the construction lines. That's because they're handled with a stronger line weight. Here we get some notices posted on the corkboard, a mat on the floor, and a volumetric bench. And here we get a recessed door, a palpable handle, and other details. We also get a corkboard with notes posted on it, as well as an elaborate light fixture, and even a staircase leading to a second door. You now know how to create the illusion of depth using many of the same tools Raphael, Canaletto, and professional animators use, and you'll be able to experiment with all this to draw from your imagination.